Today we will discuss about native VLAN. Okay.
Yes, sir.
So first we have to know what is native VLAN. It is used to support untagged frame on trunk link. This is the very first point you have to mention when it is asked what is native VLAN. Okay.
Hmm.
The second point, it support untagged frame on trunk link only in .1 queue, not in ISL. Clear?
Yes, sir.
By default, VLAN 1 is native VLAN. Only one VLAN can be a native VLAN over a trunk link or on a trunk link. Clear?
Yes, sir.
Native VLAN must be same in all switches in a layer 2 network. So these are the basic points. Clear?
Yes, sir.
Firstly, it is used to support untagged frame on trunk link. It supports untagged frame on trunk link only in .1 queue, not in ISL.
Hmm.
By default, VLAN 1 is native VLAN.
Hmm.
Only one VLAN can be a native VLAN on a trunk link. Native VLAN must be same in all switches in a layer 2 network. If you have 30 switches in a layer 2 network, the native VLAN must be same. Whatever it may be, VLAN 1, VLAN 10, because we can change native VLAN. Okay.
Yes, sir.
Now, what is the purpose of native VLAN? We have switch 1, we have switch 2, suppose it is FA 0 by 24, it is FA 0 by 24. So this link is trunk link. Clear?
Yes, sir.
Suppose we have a user in switch 1 and we have another user in switch 2. First Ethernet 0 by 10, first Ethernet 0 by 20. Both users belong to VLAN 10. Now it is PC1 and it is PC2. Now when PC1 sends a frame to PC2, switch receives that frame from PC1 on first Ethernet 0 by 10. Switch 1 sees that this port is a member of VLAN 10 and the destination is on trunk port. Destination is on trunk port. That means switch 1 has to forward this frame over trunk link to switch 2. Only then switch 2 can forward that frame to PC2. So what will happen? Switch 1 tags the frame with its VLAN ID.
It about 10.
Switch 2 receives the frame. Receives a tag frame. On its trunk port F0 by 24. Switch 2 verifies the destination MAC, that is a PC2, and the port on which PC2 is connected F0 by 20 from its MAC address table, and switch 2 knows F0 by 20 is a member of VLAN 10.
10.
So switch 2, after removing this tag, added information, forward the normal Ethernet frame to PC2. Clear?
Yes, sir.
This is the normal scenario when a VLAN from switch 1 wants to communicate, when a device from a VLAN 10 wants to communicate with another device in another switch having same VLAN. Clear? So why do we need native VLAN? See, we have some layer 2, you can say default layer 2 frames regarding some protocols. We have some default layer 2 frames regarding some protocols like DTP, CDP, LLDP. Dynamic trunking protocol, Cisco discovery protocol, link layer discovery protocol. These are all layer 2 frames. And all these are some layer 2 protocols, and this protocol use frames to communicate. among switches. Okay.
Yes, sir.
All these layer 2 frames regarding protocol, all these layer 2 frames regarding protocols are sent over native VLAN. Clear?
Yes, sir.
The frames which are related with DTP, CDP, LLDP are sent over native VLAN. That means in case of .1q, all these frames are sent untagged. Why? Why? Because all these frames are for switch 2's control plane. Not data plane. That means it is destined for switch 2, not for any end user. Switch 1 sends all these frames of DTP, CDP, LLDP to switch 2 itself. Not for any end user. Is it clear?
Yes, sir.
Switch 1 sends DTP frame on F0 by 24 for switch 2 itself. Not for any end user connected in any ports in switch 2. In case of .1q, these frames are sent untagged. These frames are sent untagged.
Untag.
But in case of ISL, these frames are also sent with tagged.
স্যার আরেকবার বলুন এটা।
In case of .1q, all these frames are sent untagged because they are sent over native VLAN. But in case of ISL, even these frames are tagged. This is one of the reasons why ISL is not widely used.
আচ্ছা।
Clear?
হ্যাঁ স্যার।
Note another point here. If there is a native VLAN mismatch among or between switches, CDP generates a native VLAN mismatch message. CDP message is generated when there is a native VLAN mismatch between switches to notify administrator that there is a issue of native VLAN mismatch. Okay,
Yes, sir.
clear? Any doubt?
No, sir.
Very good. So this is our topology. Okay,
Hmm.
suppose PC1 has an IP address 192.168.10.1. IP 192.168.10.2. Clear?
Yes, sir.
So it is a trunk link between switch 1 and switch 2.
Hmm.
First we will demonstrate with dot 1 q, and then we will demonstrate with ISL. Okay.
Yes, sir.
Hostname switch 1, interface GI 0/1, switch port, trunk, encapsulation dot 1 q, switch port, mode trunk. We define the encapsulation protocol over trunk link, and then we make it
Trunk.
the port trunk. Okay.
Yes, sir.
Interface GI 0 by 1, switch port trunk encapsulation dot 1Q, switch port mode trunk. Clear?
Yes, sir.
Now by default PC1 is VLAN 10, VLAN 1, and PC2 is VLAN 1. So we can get ping reply from PC1 and between PC1 and PC2. Clear?
Yes, sir.
So we make VLAN PC1 VLAN 10 G0 by 10 in VLAN 10 and Z0 by 10 in VLAN 20 in switch 2. Show interface trunk. By default native VLAN is
1.
1. So let's configure VLAN. Interface GI 0 by 0, switch port mode access, switch port access VLAN 10. Show VLAN brief. Clear?
Yes, sir.
In switch 2, interface GI 0 by 0, switch port mode access, switch port access VLAN 20. Show VLAN brief. Clear?
Yes, sir.
Now PC1 cannot communicate with PC2 because they are in different VLAN, though they are in same subnet. The subnet is 192.168.10.0/24. Both PC1 and PC2 are in subnet 192.168.10.0/24, but they cannot communicate with each other because they are in different
VLAN.
layer 2 broadcast domain. That means different VLAN. Okay? Now I make VLAN 10 as a native VLAN in switch 1 and VLAN 2 as a native VLAN in switch 2. Configure terminal, interface GI 0 by 1, switch port trunk, native VLAN 10. Okay,
Hmm.
show interface trunk. VLAN 10 becomes the native VLAN.
Ha.
Now in switch 2, configure terminal, interface GI 0 by 1, switch port trunk, native VLAN 20. Show interfaces trunk. Okay?
Ha, sir.
Now ping from PC1 to PC2. They are communicating. PC1 in VLAN 10, PC2 in VLAN 20, still they are communicating. How? Because when PC1 sends a frame to PC2, it's a normal Ethernet frame. Okay? Switch 1 receives that frame on GI 0 by 0, which is a member of VLAN 10. Switch 1 verifies that VLAN 10 is also a native VLAN. In switch 1, and after seeing the MAC address table, switch 1 realizes that switch 1 has to forward this frame over the trunk link to switch 2. So switch 1 forwards this frame without tag, because VLAN 10 is native VLAN in switch 1. Clear?
Hmm.
Now over the trunk link, an untagged frame is coming and received by switch 2. When the untagged frame is received by switch 2 realizes that it is of native VLAN, and my native VLAN is 20,
20.
and this frame wants to destine to PC2, which is connected with GI 0 by 0 port, and which is also a member of VLAN 20, which is native VLAN. Clear?
Ha, sir.
That's why PC1 and PC2 can communicate with each other.
Yes, sir.
Both are in different VLAN, but still they can communicate. Because ISL .1Q supports untagged frame. In real environment, we cannot do this because it is a security breach. Even we don't see any CDP messages in GNS3, but in real environment you can see. Okay.
Acha.
Now change the encapsulation type with ISL, interface giga 0 by 1, switch port trunk, encapsulation ISL. So you are getting some spanning tree messages. Show interfaces trunk. Encapsulation is ISL.
ISL.
Make it on switch 2 also. Interface giga with Ethernet 0 by 1. Switch port trunk. Encapsulation ISL. Show interfaces trunk. after executing every command, you must verify it whether the execution is working properly or not. That's why we have show commands for verifications. Okay.
Yes, sir.
Now ping from PC1 to PC2. But this time we are not getting any reply as usual. Why?
ISL doesn't support untagged.
Because PC1 PC1 sends a frame for PC2, switch 1 receives that frame on GI 0 by 0, it's GI 0 by 0 port, which is a member of VLAN 10.
VLAN 10.
Switch 1 knows VLAN 10 is its native VLAN, and switch 1 knows that it has to forward the frame over the trunk link for the destination. Switch 1 also knows the trunking encapsulation protocol is ISL. So switch 1 tagged it and forwards the frame over the trunk link to switch 2. Switch 2 receives a tagged frame. Switch 2 receives a tagged frame which defines this frame belongs to VLAN 10 and it wants to destination for PC2, which is on G0 by 0 port of switch 2. G0 by 0 port is member of VLAN 20. So switch 2 discards that frame. Clear?
Yes, sir.
Packet capture is not supported on this link. No, there is no debug output is showing here. Okay.